Hi friends, this is Radhakrishna. Welcome to this video. In this video, we will be talking about the coverage of satellites on Earth. How many orbits will a satellite cover the Earth in? And this video is going to be taking an example of the satellite EOS-06. This is ISRO's latest satellite, which we also called as OceanSat 3. And the mode is GAC mode, which is Global Area Coverage mode. So what is GAC mode? So this EOS-06 has a coarser resolution and has two modes, local area and global area coverage. In the image that you're able to see here, the coverage is global area coverage, and the portal that this image is taken from is Bhonidhi Vista, on which you can see near real-time visualizations of satellite data acquisitions of ISRO. So here you can go and check for the data of 5th November, and you will get this particular image that I am looking at. Okay, and here as you can see, we'll just count how many strips there are and I'll explain what the strips are. So this is first strip, you are able to see. This is second, third, fourth, fifth, this is sixth, seventh, eighth, ninth, 10, we have 11, 12, 13, 14, 15, and this is the same strip as the first strip there. So in total we have around 15 strips here. So let us talk about what this is. Okay, so in Earth observation satellites, when they are going at low Earth orbiting altitudes, what they do basically is this. Let us suppose this is the orbit, okay, and this is the sunlit side of the Earth. Let's imagine the other half of this particular sphere on the back side will be the dark side or the night side. So when the satellite is going from pole to pole, let's say, and this is a polar, let's say, sun synchronous orbit, let's say. So when it is going from pole to pole, it is going to image this Earth as it goes from top to bottom. Okay, and when it goes back, it is the night side, right? So let us say that the time that the satellite takes to complete this orbit, let's say it is t. Okay, now once it completes the full orbit on the front side and the back side, the Earth would have rotated a little bit, right? So for example, if this is India, the next orbit would have been for Saudi Arabia, right? So this would have been the next orbit because the Earth will rotate in 90 minutes. Okay, and that's the philosophy of this coverage here. So here you're able to see India, and because the satellite again went down and backside and went again up, in the next orbit the Earth has rotated and you're able to see Saudi Arabia and then Africa and so on and so forth. So this is the philosophy of the coverage. Now what we're trying to do here is we're trying to calculate how many orbits will we get and how do we calculate that from. So that we can actually get it directly from the first principles, and this is a rough guesstimation. Accurate calculation, again, you can do it from different calculations. So basically for any gravity based orbits, what is the first principle is we have, let's say this is satellite, we have gravity equal to centripetal force, right? So tangential velocity, and this is gravity. So from here, and when you substitute v equals to r omega, and omega is 2 pi by t, which is t, where t is the time period of satellite, what you will be getting on solving this is t is directly proportional to 2 pi into root of r cube by gm. Okay, so this is the time period of the satellite, and here r will be radius of Earth plus the height of the satellite from the surface of the Earth, which we call as altitude, right? And g is universal gravitational constant, m is mass of the Earth, which is I think 6 into 10 power 24 kgs. So once you substitute all this, radius of Earth we know, and height of the satellite for E06 is 740 kilometers. So this is the low Earth orbiting satellite, and RE you can take it from constant. I think this is 6,400 kilometers. Once you substitute all this, you will roughly get that the time period is around 93 minutes. Okay, the time period is around 93 minutes. So what it says that the time period is around 93 or 90 minutes is basically it takes 90 minutes for the satellite to go from daylit side to again come to daylit side, or let's say from one point to another point in the orbit. Okay, now how many In one day, how many such orbits can it make is 24 hours. 90 minutes is again 1.5 hour. So this is, how much is this? So 24 by 3 by 2, which is 16, right? So this is roughly 16 orbits. Okay. And if you do the exact calculation of 90 minutes, this is going to be a slightly higher value. So it is going to be around 15 point some decimal value, right? So the satellite can do roughly 15 point some orbits, and that's exactly what you're able to see of 15 orbits completed. And there is, because there is an extra orbit there, we are able to see an extra data also coming in the first and second orbit. There's a little bit of overlap, right? So yeah, so that's what this is, and I hope you understood it, and you can actually generalize this for any particular satellite. So now you can kind of calculate this for Landsat or Sentinel and see how many orbits will it cover, and then based on the swath of the satellite at a particular latitude, you can also try to calculate how much area it will cover in a day and how many days it will take to cover the whole Earth, so on and so forth. So those calculations are a little bit complicated. We'll go through all of that. But yeah, I hope you got a good learning from this video. I'll meet you in my next video. Bye, guys.